Good morning, all. I welcome you all for our next lecture class. So today we are going to discuss mesh analysis. In this, we are going to discuss how to solve the problem in mesh analysis. So before enter into the topic, we have to recall what are the key components we are using in this DC circuit, what is DC circuit and Ohm's law, Kirchhoff's laws, all those things. And DC circuit, we know that it is the current flow in a single circuit. We can say it is the DC circuit. And also, and there are a few components basically we are using. What are the basic components we are using in the circuit? Anyone? Yes, of course, it is RLC, that is resistance, inductor, and capacitor, and also called as the passive element. And anyone can say play example for active element is diode, transistor, etc. Very good. And what is Kirchhoff law and voltage law? So normally voltage law is sum of all the voltages around the closed loop is equal to 0. And current law, total current enter into the node and total current leaving from the node. Very good. Then just we have to see what are the topics we have to discuss in this class. We are going to discuss that is what is mesh analysis, steps to perform the mesh analysis and solving the simple problem and the real world applications. Very good. Then next is what is mesh? Mesh is a DC circuit by applying Kirchhoff voltage law, and according to that, we have to, based on the KVL, we are forming the equation and solving finally the current, unknown current in the given circuit. Based, this is the mesh analysis we are going to proceed. And advantages of mesh analysis is, yes, it is easy to form the equation and solve the equations for the complex circuits and find the currents. All right. What is mesh actually? Yes. Always we can say this loop that does not contain any other loops within the within it, and simply we can keep in mind the point start from a starting point, and it it's across some components and end at the same point, and without breaking the loop. That is called as a loop. Okay, then what are the steps we have to follow for this? Means it is first we have to identify the meshes. How many meshes are available in the circuit? Anyone can say how many meshes are available in the circuit? Yes, of course, it is three. That is loop 1, loop 2, loop 3. And first we have to assign the currents, and next we have to apply the equation for apply the KVL at each loop and write the equation and solve the equation and find the unknown current. Okay, these are the steps. What are the steps we have to follow? First we have to find the mesh, identify the mesh and assign the current and apply the KVL and write the equation. Finally, we have to solve the equation and find the currents, branch currents. So 5 steps you have to follow. So just you have to keep in your mind. And this is the simple problem we can discuss. So there are two loops are available. That is, we have to give a name A, B, C, D. Here itself you have to give D, and E, F also it is possible. Nothing wrong in this. So first you have to follow the equation A, B, C, and end at the point through the 120 volt source, and at the point A, the first loop we consider the current also in the direction I1, and I2 is the second loop. It is purely assumed yourself. So maybe the direction is clockwise or anti-clockwise. It is also R wish. The current is I1 and I2 also. It is R wish only, because we have to find the unknown current of the particular loops. So first we have to say that is minus 30 I1 minus 10 I1 minus I2 plus 120 is equal to 0. So first how to write these equations, that is minus 30 I1 and that I1 Why we are giving minus in front of the 30? Because the current loop and the node loop is the same. Then we can give a minus in front of the value. That is 30 I1 minus. So second value comes from B to C is 10 minus I1 minus I2. Why? Because the 10 resistance um, available between the loop 1 and 2. So first we have to consider the loop. That way we have to write I1 minus I2 plus 120. The value enter into the negative of the supply. Then we can put plus 120, which is equal to 0, and rearrange the equation. Finally, we get 440 I1 minus the 10 I2, which is equal to 120. That we call the equation number 1. And likewise for the equation number 2 is and that is minus 50 I2 minus 60 minus 10 I2 minus I1. That is the 50 I2 is why we put minus, already I told you. That is the node flow of node, and that is the direction of mesh, and the mesh current is all both are in the same direction. Then only we have the minus, or otherwise we have to put plus. And the current flow through the 50 ohm resistor is I2. The minus we are putting in front of the source 60, that is the current enter into the positive terminal. Then we can say it is the minus, and 10 I2 minus I1, because we are considering the loop to I2 minus I1. So rearrange the equations and solve the equations. Finally, we get the current I1 minus I2, that is I1 is 2869 amps, and I1 also, and find the I2. Finally, the current, if say they are asking a current flow through the 10 ohm resistance I1 plus I2, then we can say it is a 3.39 volts. That is I2 is 0.521, I1 is 2.869, and the current branch is BC, it is 0.521. Finally, I1 plus I2 is 3.39. And this is how we are calculating the current I1 I2 for the given loop. And mesh current is the empathy for the objective and the users needs, observations of the user needs, and finally we have to solve. And these are the real world applications: power supply, electronic devices, automotive supply, renewable energy systems. And here all these are the application, real world application for the mesh. And this is summarization. What is, first we have to recall terms, what are the key components, Ohm's law, Kirchhoff law, current law, and the steps we have to follow for how to find out the loops, and how to apply the KVL, and find based on the KVL we are making the equations and solve all the equations. Finally, we find out the unknown current. This is the procedure, and the summarization of this session. And these are the references just you have to follow. Thank you all. If you are having any queries related to mesh analysis, please ask. Thank you. See you in the next class. Thank you.